Ashish, pronounced right?
That's right.
What was your first computer?
Oh, my first computer was a compact Rosario Windows 95 Pentium 1 with MMX technology. And I think we used to joke about how heavy it is, even though it was just 2 gigabytes hard drive with 16 MB RAM.
Wow.
And this was in 95 back in India.
Wow. So you're very young.
Oh, well, yes.
So what did you do with the computer?
It was mainly for playing games with the occasional, playing around with QBasic and GW Basic. It wasn't. I didn't start programming very early.
What games?
Golf,
right? Golf, chess.
Chess, and because this was the MMX technology, I also played some multimedia games like I forget the name of. I think it was Pod Car Racing.
Man, chess was just joke,
Chess. No, I used to play chess.
Really? Me as well, but not with computer. Was okay. You are from India, so cricket was cricket, virtual cricket.
Yeah. Now that you remind me, yes, we used to play this game called Allen Border Cricket in the MS-DOS world.
No kidding. This was another joke. Yeah. Okay. I thought, what I think is, you played, Quake or something like this, and now you're telling me stories about cricket and,
Yeah. That's true. Not so much Quake and first-person shooters, but yeah, definitely more in the car racing, the sports. Yeah.
With Pentium, what I played, Dark Forces? It was Star Wars game, it was like a Quake, but with Star Wars. So I was fascinated by the game. Probably Pentium 2 or 3, not 1, but yeah. Mm-hmm. Your Pentium was 75, you remember? 75 megahertz, I think? No, yeah, megahertz. Yes.
I think so. I think it was a Pentium 586. I forget what the clock speed was.
What I remember was there's one 66 and the other one was 75 and then 133, I guess. And I got the first one 75, so it was pros. It was not the 66. Nice. And why QBasic and GW Basic? This is because on PC is not the natural choice to pick Basic.
So I used to take some computer classes at the time, and this was something that we came across over there. School curriculum was also focused on the basic programming languages.
So then, how you started programming, or how it happened?
Oh, I started programming when I think it was 8th grade onwards, and I wanted to do some cool. Learn something that I could essentially command a computer to do and try to automate bits and pieces of my life. Yeah.
What automate? I mean, what do you wanted to automate? What?
I mean, I was essentially trying to recreate a calculator from scratch, right? And one of the early things was to do all sorts of math without essentially pulling up a calculator. Just essentially writing a program from scratch to do that. So, yeah.
Incredible. Mm-hmm. So amazing guy, So you were fascinated by math, or you had to do this?
No, I was fascinated by math. I always was interested in essentially finding efficient ways of executing something end to end. Finding my first job was also in the financial services industry, so that was a lot more helpful at the time.
Okay.
And essentially come up with financial models and also mathematical models that I could then validate quickly and then put into production.
But this was later, right?
This was much later. But, that thing always kept ticking in my mind. And I think that was one of the core drivers to get into programming and computer science in general.
Okay. So your first program was still BASIC. So you learned QBasic in GW Basic. And what was the next language?
Oh, the next language was, I believe it was C and C++.
Why that? How you learned that?
This was also something we did while we were in high school and through the years. And even through engineering school, we had the same thing. Before Java became more mainstream in college, that's what we focused on, C and C++.
And what you did in your leisure?
In my leisure, I used to read about algorithms.
Really?
Yeah. I always thought that programming was a way to just put that in motion, but the math behind that used to always fascinate me, and that's what I used to like to dabble with.
And this is incredible. So you in your leisure, instead of playing something, football or whatever, cricket, you just enjoyed algorithms.
Yeah. It was fun.
About algorithms, I also during my study I tried to learn algorithms, but it was not easy for me just to read the book and get the algorithm. So what I did is I implemented them. So I had a lot more fun in just doing something with it. Were you more the theoretical guy? So was it enough for you to read the book, or you tried to try it out on your computer or in your machine?
Yeah, no. So I mean, definitely, I used to do a bit of both, but I like the theory aspect of it. The fact that you could actually model the whole thing on paper and then put it in motion was a lot more valuable. Yeah.
How you model that?
Just essentially writing out the math equations for the base case and the incremental case. So if it works for n is equal to 0 and n equal to 1, and then n equal to n, then you essentially can scale out the model as much as possible. But yeah, it was a more academic approach to that.
Okay, so let's say a for loop with an if statement.
Mm-hmm.
How to do it in math?
For loop with an if statement.
Yeah, for loop, and inside of for loop is an if statement with a filter that every modulo 2 happens something. You have two sets. One set is odds and the other not. Is it possible to model like this? In math, or already what I said, is already a solution to your model. You know what I mean?
So yeah, I mean, of course you can model everything in math. That's how flexible math makes it. The idea is obviously you obviously have a set of data to work with, and you identify which ones would actually go through the for loop. And in this case, it's everything. Then within that, the block that it will be satisfied will be managed by the if loop, and then that's where the probability comes into.
Now, so what I'm interested in, how to express a program in math. So what I understand is you have a kind of, a problem. So you can model the problem in math, but the design of a programming language, I cannot just imagine how to write this with math equations. For instance, if statement or something like this. This is like too low level, right? You wouldn't do this in math. Or
no, I mean not specifically just model every line of of your program in math. It's more about calculating the complexity to identify which one makes more sense when you have two possible solutions to do it.
Like big O notation, something like that, right?
That's right. Yeah.
Oh, okay. This is what I get. Okay, yeah. But even a sorting algorithm would be challenging in math, right? Isn't it? So could you just express quick sort in math?
Yeah. Well, not always. I mean, with quicksort, obviously you have the probabilistic aspect of picking I forget what we used to call it, the pivot around which you would sort all the elements. And no, that's definitely something that's already available in math. It's actually well documented pretty much in every algorithm book out there.
No, my algorithm book was actually in C, I think. It was not with math equation. Okay, interesting. Because I always wonder myself, how easy it is to just read a mathematic paper and immediately get it, what it means.
Yeah.
And you got it? You could just read, math equations and what it means immediately, or not?
No, I would have to dabble with it a little bit and draw, the actual diagrams and stuff just to make sure I get it. Essentially, talk to myself.
Okay. Yeah, I will even try.
No, I wish I could do that. I wish I could do that.
The question is, are there people out there which are able to understand it? How we read code, whether there are people who can read math the same way. Do you believe that?
I believe I have seen some folks. I think I know some folks who can do that.
Okay. Perfect. So this is so sorry for the distraction from our actual topic.
No, not at all.
Okay, so no kidding. You started C and C++ to be to solve math problems faster, right? And why QBasic was not enough? Because you knew that C is faster, or you had algorithms available in C and C++.
Well, partially that, and partially because obviously when you look at what the industry is pivoting towards, you want to make sure you get the tools that actually hold value out there. Basic and stuff that essentially moved away from the mainstream.
So you were business driven as well, right? So you want How old were you? If you started to program C, how old were you?
I was in eighth grade, so I think that was about 13, 14. Yeah, about 13, 14 years old.
Amazing. And you had life outside the computer? So you did something outside or not? Yes?
I did.
Okay. Now,
I did.
How much time you spent with the computers in 8th grade? I'm just curious.
Oh, we were time boxed. It had to be a couple hours a day at max.
Couple hours a day is at max. Okay, so there's
yeah. And only a few times a week, just so that we didn't get addicted, because that was the thing.
So, and then you started to study, you said. Or you mentioned engineering school. What is an engineering school? Is it something between high school and study and university?
Well, no, that's university, essentially.
Okay.
That's the four-year undergrad. Yeah.
And what you did at the university? Which computer science?
Yeah, so computer engineering.
We
didn't really have a computer science focus. Yeah, but so it was computer engineering. It was obviously a mix of the actual microprocessor bits along with programming principles.
The same, yeah. Okay. And where was it? Which university?
This was in the University of Mumbai in India.
And it was nice experience?
It was a very good experience.
It was crowded.
We had a lot of like-minded people.
And how to imagine such a university? Is this a large one, a small one, or what's?
So the university actually manages multiple colleges,
Okay.
individual four-year schools where you actually go and get your instruction.
Mhm.
But the degrees are always given by the university, obviously.
Okay.
So it's a little more of a distributed model if you try to use computer science paradigms over there, wherein you would essentially enroll with the college which is affiliated with the university.
Okay. And
Yeah.
was it a relaxed studying, or was it stressful for you? You enjoyed that, or what?
It was enjoyable. It was definitely enjoyable. There were a lot of like-minded people who would essentially want to get achieve similar goals.
You wanted just to read, algorithms all the day, right?
Yeah, well, that's one way to do it. We did have a lot of fun too. not what I initially portrayed in my life, but yeah, we did have a lot of non-technical experiences as
okay.
well. Over
Now, otherwise, I would say, okay, now we have to to stop the podcast because I cannot just follow your ideas.
No.
Okay, nice. And what you did, something, I don't know, not interesting, rather than something different to math in C and C++. Was something like this, or we just fully focus on math?
Well, one of the most interesting things that I really enjoyed doing was essentially rewriting an entire SMTP server using only C with Berkeley sockets. And that's one of the obviously we were like, okay, let's make a web server. That was pretty straightforward. You open a socket from the client to the server. You open up a bunch of HTML files and you send them back on the wire and render it on the browser. But essentially changing that and saying, okay, you know what, I'm going to start a command line prompt, send an actual email, and then have it replicated across the different instances of an SMTP server, and using only C with Berkeley sockets. I think that was one of the most interesting projects I did.
This is how Nginx happened, yeah?
Yeah, that's right. That's exactly right.
No, SMTP, what I remember is hello, right? Not hello, right? Hello.
Hello. Yeah,
hello, exactly.
Right.
You could do actually SMTP with Telnet. I tried the same with Java. Actually, I think it even worked basic stuff with Java. I used the Java socket to do similar thing. But I was actually not disappointed, but concerned how primitive it was, that we have actually parsed the strings and sent hello back and forth. For me, it was like, I started with SMTP as like, wow, this is something interesting. And then I look at the code, it's like, actually, just sending those strings back and forth, and it still works. When you learn Java?
Yeah, so in my 4-year program, we did quite a bit of Java, but I kept falling back in love with C and C++. And, it was a sadistic notion of wanting to see segmentation fault when something goes wrong, as opposed to a nicely formatted error message.
Yeah.
But then once I came to grad school, we really went deeper into Java, and through my first job as an engineer, I played a lot with Java and Spring and that ecosystem as well.
Which Java version was it?
Oh, I think it was 1.6 when 1.4, 1.4
really
when I started, and then 1.6.
Okay, these were pretty modern times. I mean, 1.6, it was already incredible. So 1.6, 1.7, so you already knew annotations.
Right.
And you did Spring with lots of XML or already with annotations? You remember that?
Lots of XML, obviously using all of Spring's core competency and stuff like, dependency injection.
And you enjoyed the XML part?
Yes and no. I liked how, you could obviously do everything in configuration for the most part. So obviously once you were through with the learning curve, it made maintainability a whole lot easier. It was easier to document. I appreciate that there's an option to do everything in configuration that essentially can then be piped into your documentation as well.
Okay. I also appreciate that, but I never did it in the last 10 years. I know that it's possible, but believe me, in usual business projects, you have one path and you never have to reconfigure that. This is the sad truth. Yeah. Okay. So what was your first job? Financial industry, you said?
Mm-hmm. Yeah. So I was a quantitative developer associate with Morgan Stanley.
But no more in Mumbai, right?
No. This was in New York, right after my grad school. Yeah.
So after university, you move away from India to where?
So I moved to New York. Yeah, and then I was enrolled for my grad studies at Columbia University.
Uh-huh. And you like it more than Mumbai, or was it equally nice, or what was your impression?
It's comparable. Big city, overcrowded, lots of people, lots of chaos, comfortable chaos.
Okay, so I say chaos is chaos, no difference.
Exactly.
Okay, and after
it's always a melting pot. Yep.
Okay, and after the study, what you did then? You started at the financial district.
Yeah.
Okay.
Mm-hmm.
And did you enjoyed XML? with Spring?
I did enjoy XML with Spring. Again, like I mentioned, the fact that things could be more standardized, it was easier to get your hands dirty with the code, actually understand what you were looking to build end to end. Even though you need to have some domain knowledge in the space, and while you build that up, at the very least, the rest of the stuff is a little more standardized in terms of what's your configuration look like, what sort of code you need to write. So that was a more familiar space to be.
This was your last job before Microsoft, or was something in between?
No, this was my job, after which I moved to Microsoft.
How you found a job at Microsoft and how you applied? This is the interesting part.
Well, I was looking for, obviously I had done a lot of hands-on programming, and I wanted to, I kind of thought I could empathize with the issues that developers face. And I essentially started looking for roles where I could help build tools for developers.
Okay.
And really energize their essentially modernization and solve their core complaints and problems with the stack that they work with. Okay. So that's what I essentially packaged up, and I started applying to Microsoft, and got lucky.
This was the Microsoft Asia, right?
No, this was Microsoft in Seattle, in the Redmond, Washington area.
Yeah, but for the Azure Cloud from Microsoft, right?
Oh, yeah, for the Azure Cloud, yep.
Because otherwise I would say, why Microsoft cares about developers is just because of the cloud, right? Otherwise you would be .NET, something like this.
Well, yeah, so there are a couple of things, right? Obviously, Microsoft is a productivity company that wants to make, empower every person and individual and organization on the planet to achieve more. And as it plays out in the context of the cloud, is to essentially build out the right tools that developers and startups and anyone who is essentially building a solution can definitely leverage.
To move more developers to use Microsoft Cloud, basically, right? So this is the basic idea behind. Yeah. By the way, I was on the other side of the equation. So I worked. I really like Sun Microsystems, and then Microsoft was never on my radar. But recently, it is almost like the Sun Microsystems from back then. It's this complete different company, which I really appreciate right now. And I don't know whether you know Bruno Borges. You know Bruno?
Yeah, we work with him. Yep.
Yeah. Okay. And this is also we had on the show, and yeah. So when you started at Microsoft, when was it? When?
So it was 2016, early 2016. Yep.
So what you achieved in the 4 years? What you did at Microsoft? So which Asia's department are you working, or what you are doing exactly?
Sure. Yeah. So I'm a program or product manager on the Azure messaging team, and I work on Azure Service Bus.
Product manager. So you are a big deal, hell. We have a casual conversation, and you are like the highest guy on the Azure Microsoft team. Okay, how it's called? Messaging team.
Messaging team, Azure messaging. So this takes care of all your messaging, command, eventing scenarios. So we essentially manage Azure Service Bus, Azure Event Hubs, Azure Event Grid, Azure Relay. And that takes care of all of your command control, event streaming, reactive event programming. And me personally, I work on the Service Bus team.
The Service Bus, which hopefully has nothing to do with the Enterprise Service Bus, right?
Which, no, except for the fact that its paradigms are comparable with message queuing and point-to-point and pub-sub semantics.
Okay. I already suspected that you might work in this area, and I take a look at the Microsoft Azure Service Bus. This is the official name, right? Looks interesting. That's right. So it seems like in Java I would communicate with AMQP with the service. Is that right? What I don't get, so I took a look at the spec, and they are like two flavors. The one is like using the Microsoft APIs, and the other one using JMS 2.0.
That's right. Yep.
But if I would go ahead.
No, go ahead.
Yeah, and what I wanted to ask you, because usually, something funny, a little bit of history. I think 15 years ago, I wrote a blog. What happened was at Sun Microsystems time, there was a project called Glassfish, like a server. Bruno Borges knows about that. And the Glassfish was part of Java EE, and Java EE comes with JMS. And there was another project at Sun Microsystems called the Project Darkstar. And the Project Darkstar was a gaming server.
Right.
And they used Glassfish. And what they wanted to do is to have an own messaging stuff just for the gaming server, right? So
I see. Yep.
And I said, okay.
Lower latency.
Yeah, and I said, okay. But why you not just implementing JMS, then we could get no low latency JMS. And the answer from them was we cannot do this because JMS doesn't scale. You say, hey, look, JMS is just a set of interfaces. It can scale or not. There is nothing, inherited in an interface that it doesn't scale. No, we cannot use JMS. It doesn't scale. And this went back and forth. I documented even parts of this conversation on my blog as a comment. And what I saw in the Asia is you can use JMS too, but you're mentioning AMQP. Actually, if I would use the Azure Service Bus JMS, it would just communicate to your cloud regardless what happens behind the scenes, right? I don't care about the protocol. I could just use JMS 2.0 and go ahead, right?
That's exactly right. So obviously AMQP is the new industry standard that we've been pushing for. It's advanced message queuing protocol.
Yeah, and this is a big misunderstanding that JMS is nothing about protocol. It's just a set of interfaces. And AMQP is one of the view protocols, which is standardized, right?
That's right. So JMS itself is just a set of interfaces, like you rightly said. Yeah, it's just the implementation is over AMQP, and AMQP is essentially the new standard that's leveraged by pretty much most of the enterprise brokers out there. ActiveMQ. Yeah. Rabbit does a AMQP 0.9, but it's essentially out there. And for most folks, obviously the protocol implementation is just another implementation detail. Yeah. It's not something that the application typically cares about unless you have super users who have a specific preference of which ports they want to open and stuff like that. Yeah. But it's just an implementation detail for customers.
So let's think about some potential use cases. What I thought I could do with your service bus is the following. I can have my server runtime or whatever. And hopefully without XML. So this is just my word, right? and then
your choice.
Yeah, of course. And then send a message to a topic or queue. Let's say to my local. Let's make a little bit more complicated ActiveMQ server. And this ActiveMQ already talks whatever, and I could register a listener which receives the message and pushes with JMS or without. It doesn't matter via AMQP to the Microsoft Azure cloud. And then I could have, Azure functions or whatever. And this will be the integration point between my enterprise or the Azure, right? This is some valid use case where I can push from my cloud bursting, whatever, from my local private cloud, some messages to your cloud. And now we are integrated. Because if this is in Azure Service Bus, everything is transactional already in the cloud. And then a function can wake up, read it, consume it, and do something with it, right?
That's exactly right. And the core focus here is, a couple of things, right? Firstly, you have the same familiar API that you use to leverage, send and receive functionality onto a queue, right? And what that means is that, in the example that you mentioned, obviously you're using ActiveMQ as a local queue that will then forward to Service Bus. So we're going one step, we're going one step further and saying if you have an existing application that's living on premises and that's leveraging, some sort of message queuing solution or JMS providers, let's say. And you want to essentially move it to a modern cloud-native solution, a cloud-based, fully managed enterprise PaaS or enterprise messaging PaaS, which is Service Bus. All you need to do is essentially plug in the dependency in your POM XML and just change the configuration settings to point to Service Bus, and you're good to go, right? So your application code is completely agnostic of which JMS provider, JMS broker you're talking to, and Service Bus is now supporting it as a first-class experience.
Yeah.
Right.
What I will need to do is a little bit of bootstrap, I guess, the connection factory get or something, right? So I will have to package, otherwise it just won't work. But so there will be probably one line of Microsoft specific code which I can hide behind a producer, and then I could talk directly to the cloud, right?
That's exactly right. And actually with the Spring, obviously we have a Spring starter as well. And in that case, you essentially don't need any Microsoft specific code. All you do is essentially plug in your POM XML. And in the application.properties file, you just plug in the service bus connection string and the timeout, and boom, you're all ready.
You heard about Quarkus?
About what?
Quarkus.
No, I'm not too familiar.
This is not possible almost. So Quarkus is something like Java-y, Jakarta-y, modern runtime, very modern runtime. And why I remember Quarkus right now is because what you said is you are using familiar APIs.
Right.
And it's exactly the same with Quarkus. What they are saying, they're using familiar APIs with modern runtime. And Quarkus now it takes off. It just uses, the micro profile and Java APIs, also parts of JMS.
Right.
And this would be a natural fit because in Quarkus, I could just have an extension which pushes directly to the Microsoft cloud. And lots of my projects right now are using Quarkus. Take a look at Quarkus, you will like it. So you could
I will check it out.
completely integrate Quarkus JMS in Quarkus just with extension, for instance. And regardless how, most important is JMS 2.0. This is the integration point. So it means in most application servers, you will need like a service locator. In Spring, you can use XML to configure that. In Quarkus, you would write extension to instantiate the factory, and it will be completely integrated behind the scenes. You know Graal VM? Graal? So Quarkus uses Graal, which cross-compiles Java code to bytecode, which makes Quarkus tiny.
I see. Yep.
This is the thing. Okay. So we have the integration point with your Azure cloud. So what else? What is the another use case of the enterprise service bus, Azure Service Bus, ASB. So we have now integration point with the on-prem. What you can do. What else? What would be the killer use cases of you are the product owner, so tell me something.
Yeah, absolutely. So obviously, with so there are two things, right? The two themes that we try to focus on is lift, shift, and modernize. Typically when you're talking about a cloud-based service, you're saying lift, shift, or modernize. We want to focus on both, right? So let's say if you're coming in with an existing application, fairly legacy that you want to essentially modernize, you move the compute bits, and you take the broker, and you'll be like, okay, I'm going to move. I'll probably think about hosting, my existing broker on an Azure IaaS setup, or you know what? Hey, we have Service Bus that uses the same thing. Now you can replace your Azure IaaS hosted broker with Service Bus, which is a fully managed PaaS. And then on the receive side, let's say you're doing something that's kind of pre-baked, or something that we can leverage a serverless solution for. As you migrate your application stack into Azure, you can start considering moving those or replacing those bits with logic apps and functions, simply because we have that native integration with everything, everything that's Azure first party.
Yeah.
So you could have, and you kind of touched upon this earlier, wherein you have the Azure logic app or functions, which is essentially listening in on a queue or a subscription. And at that point, if a message comes in and let's say you're running a CRM system and you want to send your customers an email, reminding them of an appointment or something, you could just have a pre-baked logic app that takes that message, puts it into an email template, and just fires it off to all these customers.
Okay.
In the past, you may be having some sort of custom code that uses, Java X Mail and a whole bunch of other stuff that was leveraging this. It's all gone. Now you have a serverless solution that you do, as a pay-as-you-go consumption plan.
Yeah,
and you're good to go.
Yeah, in my Java XML, I would have to specify the session and some configuration. And in your case, I would still have to specify something, right? No.
You would. But you no longer have to worry about essentially hosting that on an AKS cluster or a VM. You can just have a logic app that's all set up for you to just leverage pre-baked.
Yeah, I know what you mean. For managers, it makes sense. For me as a developer, I never had to manage the class because it was already a part of the system,
Right.
You know what I mean? So, but I get your point. This is not a killer use case. What it could be a killer use case, let's say I have another modern app which already runs on Microsoft Azure. And this app is hooked to, let's say, I don't know, Azure queuing system or whatever. You have?
I see, yeah.
And this Azure queuing system is the native communication system in the clouds. What I can do right now is I can send a JMS message which is consumed by Azure function. And this Azure function stores that natively. It's like an adapter, to your native queuing system or Kafka or whatever. And this is the integration point. Because with Java, implementing logic, we are pretty fast nowadays. So there's not lots of value to moving this existing function to a Azure function. But I think the big deal is, integration with already existing cloud native systems with completely different protocols. I don't know, machine learning models or whatever you have, so whatever exists. And I would like, to talk to this thing. I could say this, your service bus sits in the middle. It understands all the Azure technologies. I just push the image, then a given function wakes up and does something for me, right? This could be an integration point.
Absolutely, yeah. So from the point of having logic apps and functions, that essentially opens up the door to all of the other Azure pieces that you can leverage. Simply because that's essentially the starting point, the front door for everything else.
Yeah. What is a logic app? What is a logic app? Because I use this Azure Kubernetes system. Is a Kubernetes logic app? No.
No. So logic app is essentially a no and low code pre-baked set of steps that you can use a UI to configure. You have the Logic Apps Designer,
like a step function,
and
like a workflow with functions.
Yeah, it's exactly. It's more of a workflow. The step function will be more towards functions, but Logic Apps is essentially workflows that you can design using a UI or whatever else, and then essentially you can package it up and either run it serverless on Azure itself or in an integrated service environment that you fully control.
Is the Logic App part of the Azure Service Bus?
It is. No, it's a separate product.
Okay.
Azure Logic Apps. But yeah, in the past we've essentially sat in the serverless PaaS ecosystem and part of the integration work streams.
Mm-hmm.
So it's definitely got we're obviously going to make our integrations better, but even right now it's essentially one of the more modern applications touching Service Bus.
Okay, so it's like a visual designer which creates workflows, and the workflows gets persisted, and every task in the workflow is probably a function which wakes up. You passes the context from outside, it executes some logic, and then it just disappears, right? It's stateless again.
That's right. Yeah.
Okay.
Yeah. So this is less about custom code. It's more about specifically workflows which leverage other integrations with, let's say, your Outlook or Office 365 account. Wherein you want to send an email, or you would like to, essentially have a forwarding logic wherein you want to take stuff from one queue and push to another queue.
Yeah. Are you aware of Apache Camel?
I have.
So something similar to Camel, but visual and without coding, right?
That's right. Yep.
Okay. So this JMS 2.0, which features are you not supporting? You know that?
So in the past, we used to have JMS functionality, which was more of a artifact or just as something we supported for free because we were AMQP. So that was there's something called the JMS Technical Compatibility Kit, which is a percentage score of how many features you support.
Yeah.
So we used about 38% before. We are now up to more than 90%.
Wow.
And the idea is to essentially close the gap completely, right? And so the idea is that we want to get to full JMS 2.0 parity.
Mm-hmm.
And what that means is essentially we will have all the features. Every JMS API contract will be supported. We already support these in our preview as well, which is queues, topics, temporary queues, temporary topics, subscriptions, all four kinds, which is all possible combinations of shared and durable. So shared durable, shared non-durable, unshared durable, and unshared non-durable.
Amazing.
So these are already available. There's also the concept of queue browsers and topic browsers, and all of these are supported with message selectors, which is similar to our filtering functionality that we already have with Service Bus filters and actions.
For the audience, the selectors is like a SQL 99 syntax where you can filter the message headers and say, okay, I'm only interested in this functionality. Not bad. Okay.
That's good. That's right. Yeah. So essentially, when you send to a queue or a topic, and obviously with the queue it remains on the queue, but with the topic it's forwarded to a subscription, you can selectively forward your messages to multiple subscriptions depending on which one matches the filter condition.
Mm-hmm.
And that's basically where a lot of complicated workflows can be orchestrated right within the service bus or the message broker itself.
Mm-hmm.
So that now your applications will only look at the data they need to, and they can start pulling and processing those appropriately.
Right? How durable can it be? So for how long the message get retained for me or stored?
So when you pick a durable entity, right, it is persisted to the service bus storage for as long as you need it, right? And what that means is that when you send a message and we ACK it back to you, that means it's triple replicated. So we have 3 copies on our backend storage,
mm-hmm.
and only then we will ACK it back to your sender application. The same thing applies for the receiver as well. When you receive a message, we essentially lock the message on your behalf, and only after we get the positive acknowledgement to remove the message, from your receiver application, that's when we will actually go ahead and delete it from the storage.
Okay.
Right. So in a standard JMS setup, you can have a message handler wherein depends on how you program your JMS session. You would say, I want to do an auto acknowledge, which means
mm-hmm.
at the start of the block, please lock this message for me. I will take my time to process it, and then when I go and complete the message, or when the block ends, I will go and essentially indicate to the broker that now the message is processed by me, and now you can remove it from the queue.
Okay. Is in your case dubs okay acknowledge faster, or doesn't make any difference? You know that?
So that's the thing. So right now, while we are at the 91%, we support auto acknowledge. But as we close the gap, we're going to support the session transacted and the other modes as well.
Okay.
Yeah.
Because back then, the duplicates key acknowledge was faster than the others. This was the only reason to use it, because some providers were faster and the others were not. What it means is I will have to control transactions manually because they cannot be managed in your case, right? There's no wraparound. Usually on application server, if you have, for instance, a message-driven bean, which is listens to a message, the server will begin a committed transaction, and on runtime errors, it will just roll back the transaction. In your particular case, on errors, if they happen, that's the same, right? So yeah. And do you have something go ahead.
So actually, when there's an error, you will essentially throw an exception, and then that will essentially give up the message lock or the message lease that the JMS receiver has procured on the message. But with the transactional scope is still localized to a specific service bus entity, right? So we are expanding that to essentially have cross entity. So across one queue, one topic, or two queues, you will have a transactional scope. One of the things I want to call out that we don't support yet is the distributed transaction.
Yeah.
So there are obviously enterprise systems that require you to pull a message from the queue, put something into the SQL database, you go and actually complete the message. That is something we don't support right now.
Yeah, but I mean, this is really hard to support. This is two-phase commit protocol is almost impossible to implement right. And I would say you can try that, but if you start with that, it is really hard, to do it right, I would say.
That is correct. And actually, it's partially, with the fact that hosting a transaction manager is, something we are still looking into.
Yeah.
To actually support this across any any service bus and another system that you want to essentially extend the scope of your transaction to.
If you start with this work, you can start reading the algorithm books again, I think. lots of
validate everything.
Yeah, the two-phase commit. What happens if one doesn't answer exactly? This is now back to your grad school, I would say. So don't start it. You won't go out. Very soon. Cool, but this is actually this is impressive. And how well does it scale? Can I have how many listeners can a topic have, for instance? Do you have some tests, or is it doesn't matter? Or
so the service bus limits still apply. What we did is essentially we looked at what an AMQP JMS client would be sending, and we essentially added logic for the service bus runtime to take care of it. But the actual quotas and limits still stick. So we can have 1,000 queues and topics combined. Each topic can have, I think, 2,000 subscriptions.
Wow.
And at any point in time, for a service bus namespace, which is equivalent to an instance of active MQQ manager and stuff like that, you can have 5,000 concurrent AMQP connections.
Okay.
Right. Now these are obviously upper limits, so depending on how much and these are all computationally intensive for the broker to manage actively. So if you feel like you're getting close to pushing the limits, you have to essentially do a little bit better planning. Some simple back of the envelope math will help.
Yeah, algorithm book again. Okay.
Yeah.
And how many transactions per second? Just for fun, let's say a very tiny message and I'm sending you lots of messages. Do you have some tests? How many messages per second can you actually process?
Yeah, so when we provision a service bus premium namespace, we provision in terms of messaging units. So we can do 1, 2, 4, and 8 messaging units. On a per messaging unit level, we can expect about 4 MB, messages coming in and 4 MB messages coming out. So it's less about the number of transactions; it's more about the size of the messages that you're sending. Okay. If you send 1 KB messages and it's a simple queue that you're essentially pushing data into and receiving data from, you would essentially be able to get 4,000 give or take messages per second.
Okay. What is
now, obviously these are
what is messaging unit? Is a thread?
Messaging unit is our way of essentially earmarking compute and storage for the service bus namespace that you're provisioning.
Namespace is like a server, and inside the server you have partitions, units, right?
Namespace is essentially a logical container that contains all of your queues and topics and subscriptions. Yeah, and for this logical container, we would give some actual resources, which would be measured in terms of messaging units, 1, 2, 4, or 8 messaging units.
Like bulkhead pattern, right? So you can Okay. And how many messaging units can you have per namespace?
So you can have anywhere between 1 and 8 messaging units.
And every unit can have?
The idea, the number of queues and topics are pretty constant at this point. But yeah, the idea is that if you have any kind of spike in your workloads and you want to, let's say, it's start of business and start of business day or close of business day, and you have processing that runs around that time, you can essentially scale up your processing for only that much amount of time and then bring it back down when the workload reduces.
Mm-hmm.
Because when you scale up, you pay more money, but we bill only on an hourly basis.
Mm-hmm.
So if you use for a couple hours, if you have spiky workloads for a couple hours a day, you only pay the overage for those couple hours, and then you're back to normal.
Okay.
Yeah.
Can you have cross namespace communication?
So at the moment, we don't have it as a first-class experience. You need to write your own custom pump that'll drain messages from one queue, from one namespace, and push it to the other. But it's something that some customers have recommended that we add. So for more B2B use cases.
Mm-hmm.
So we're considering it. Don't really have any strong timelines to share at this point.
What we had in some JMS projects inside enterprise, actually, without cloud, is that there was network problems between the clients and the server. It was a MQ series back then. And the solution to the problem was that we could use so-called, I think this was called local queue. So we could write the messages locally. They were buffered for us, and they were forwarded back to the main server. And the advantages, of course, if there's something wrong with the network for a millisecond or second, they were buffered. So do you support something as well like this?
So we don't support a local queuing mechanism with store and forward right now. What we typically do is that our SDKs have custom retry so default retry policies, exponential backup, which can also be overridden by by applications who need a custom retry policy, and that will ensure that the connection is rebuilt whenever there's any kind of network hiccup. So that's where we are right now for as a possible workaround for store and forward to reduce application downtime.
This is how I started our conversation, because we know the ActiveMQ instance between was just what I had in mind. If there is a cloud, it's not necessarily reliable. I could misuse my local ActiveMQ as a cache or store and forward instance and do it, right?
Right.
But is your service bus idempotent? I mean, if I have retry, what can happen? That the duplicates happen, or is it safe?
So there's a way to have duplicate detection on the send side. All you need to do is essentially check that box and then set up a window of time within which you want the duplicates to be detected.
Okay.
So you can go from 30 seconds up to 7 days. I'm sorry.
Okay.
And what that will do is that if you send messages with the same message ID, Service Bus will silently accept the message, give you the acknowledgement, but then discard that if you send the same message ID in the last whatever time period that you've mentioned.
Okay, but this solved the problem elegantly. Because if this is the case, then it is exactly the same as the ActiveMQ. Because what this would do is it would try now to reach your server. It will poll your server anyway.
Yeah, let's say your application, your sender application sent a message and then died before the ACK could be received back. But on the service bus side, it's already taken that message and committed it to storage 3 times and sent the ACK back. At that point, the application will restart and say, "Hey, I didn't send this message. I'm going to send it again." And service bus will be like, "Yeah, don't worry, we got you. We know you have loop detection on. We'll give you an ACK back just to say this message is complete. But we'll discard it and we'll look at the original copy that you sent a few minutes back."
Okay. How old is the service bus?
No, I think we're coming up on 10 years at this point.
10 years?
Just to, yeah.
I thought you implemented this the last 2 years, so something like this.
Oh, no. So the team that is working on Service Bus is the same team that also worked on MSMQ, which obviously is one of the early queue offerings along with IDEMQP series and TIPCO. So it's the same knowledge base that we're working on.
Yeah, this is what I thought, because what you're mentioning right now is not trivial. It is well thought, and there are some corner cases we're discussing right now that already solved, and probably parts of the MTS, Microsoft Transaction Service team as well, right? I would think. And what strikes me how obsessed you are with the standard, which I really like, because if the standard is implemented well, we could actually use this Microsoft Azure System Bus or your JMS server as the main server, just, because we can. I mean, if it works well, we can just use it. It's not a big deal. We can send ephemeral messages. For instance, also for communication between sites, I have 2 locations for my company. I have 2 regular servers, and will misuse your message as a service, right? MES, message as a service platform, just to communicate between the sites and send messages back and forth.
That's exactly right. And Adam, the value add over here is not for folks to move to Service Bus and have to reconstruct their business. All they need to do is point to Service Bus, and then they can leverage everything that a cloud native service can offer, right? Which is, high availability. We have integration with availability zones across the regions that Azure supports availability zones in. You can have, data, geo-replication. We currently support metadata, so you can pair up a primary and secondary namespace, and any kind of queue topic subscription you create will be copied over. And in the event that one region is not accessible, you push a failover button, and your application can, have a recovery time objective of under 10 minutes, because your alias will just point, your application will automatically point to your secondary namespace. And the idea is that we want to close this gap and allow data replication so that you can have a recovery point objective. That is something that the customer can configure. So the idea is to essentially, how can we build a nice business continuity disaster recovery story for customers who have been, working with Java and Spring workloads for a very long time, and how can we help them modernize their application stack?
We are right after the AirHacks TV. So now, before that, it was a question and answer show, and I get questions now regarding JMS and messaging and how to use messaging in project. And I always said, JMS has nice SPI, but don't even try to cluster this thing. And the problem is, it's really hard. And why it is hard is, if you think about topics or queues, they are basically singletons. So to do it right, what you will have to do is, I think this is the only solution is, to have, one master queue and one master topic, I mean per name, right? Like the singleton instance, which sits somewhere, and then a couple of, fallbacks or followers, and then a kind of Paxos algorithm, which, elects, the leader. And this done right is non-trivial. So this is always the same problem. And how it works in your case, do you have like a master topic and then a couple of, followers, or you have, because it's a hard problem, if I send you a message to a topic, the message is there. It cannot be just, at 2 locations at the same time, except you have already quantum computing in place. There is a storage, a memory somewhere. This is the primary memory, You know how the replication is actually working?
So right now we only replicate in the same region. It's not across regions. That's something we're going to be, working towards building. Yeah. But right now we're in the same region. Obviously, we have 3 copies of the storage.
Yes, still, yeah, exactly. Yeah. But you have 3 copies of the storage. So what it means is, copy of the storage means the copying takes time. So probably what I can do is I can, adjust that. I can configure whether I have to wait until it replicates or is asynchronous. Is it right? Can I configure this? You know this?
So within the same region, we want to make it as abstract as possible. So you don't need to configure anything. Yeah. You get it by default. It's just that when you have availability zones, we'll put those 3 copies in different data centers within the same region. Oh, so they'll all be in, let's say, US East, but they'll be a few tens of miles apart from each other. And what we actually do behind the scenes is that we depend on storage. So we build Service Bus on an Azure IaaS storage, and we leverage the zone redundant storage as well, which essentially builds on top of essentially 2 out of 3 quorum rights. Yeah. So what that does is that the moment you send a message, we will make sure it's copied over to 2 out of 3 copies. And only once that is done, you'll get the acknowledgement back to you.
Yeah, and then you have like a gossip protocol which replicates behind the scenes the message across the others.
Okay, that's right. Yeah, but the main takeaway here is that we have 2 out of 3 copies already cut off. The third one is eventual consistency.
Yeah, this is why I need quorum. So if you have 5, I will need 3, right?
Yeah.
So it means the replication obviously only works for persistent queues and durable subscribers, because for transient it doesn't matter, right? So we only have the single. So right. If the queue just breaks, for me it's no difference because it's abstracted behind my proxy. Then another queue wakes up, there's another leader gets elected, it wakes up, gets recovered from the storage, and we can just process the messages.
That's right. Yeah. So basically, in the event of any kind of localized default, let's say, there's, for whatever reason, that specific data center goes down, not the region, but just one data center.
Mm-hmm.
There's a utility fault, someone cuts off the wires and stuff like that. Within those 3 copies, one's gone. Between the 2, whoever has the latest data will be selected as the leader.
Mm-hmm.
And that would start, accepting traffic from the load balancer that sits in the front.
How long does it take? 5 seconds? So I would say it stops the world for 5 seconds or something like this, and then,
That's correct. So you would barely see a momentary blip on your receive side. The send would essentially would be completely transparent.
I'm just curious. It's not like I'm just it's an interesting conversation. Yeah. So okay, now potentially unfair question. When I should use Microsoft Azure Service Bus and when Kafka?
Got it. Oh, that's not an unfair question. That's one of the most common questions.
Okay.
So the common question is, why do you have so many tools, right? And you can't have our one of our managers jokes about how you cannot drink soup with a fork, or essentially implying that you need the right tool for the job, right? And the way we break it down is to say it depends on what your definition of a message is. If the message is a directed command, from one sender application family to a receiver application family, wherein who the sender is, what the message is, and what is the implied action from your end, that's when you would essentially use Service Bus. It's a directed command. It's like talking to your boss or your direct report. You give out a bunch of commands and they execute and they get back to you. When you actually think on the other side of if it's not a command but it's an event, then you think of events of 2 kinds, right? If you have streaming events, stuff like click stream telemetry, a user walks into your website and clicks all over the place. You want to essentially study their usage patterns, or you have an IoT sensor, temperature pressure sensor in the field, which is sending you minute by minute or second by second, pressure sensitive and temperature readings, and you want to essentially graph those out or process those appropriately or find out anomalies in that. That's where you have the streaming event scenario. That's where you would use event hubs, right? And event hubs, the way you can look at it is it's like a queue from the front, and a data warehouse from the back. And when I say event hubs, I kind of conflate event hubs and Kafka because they're comparable scenarios. And now because event hubs supports the Kafka protocol, you can also use the same way you would bring JMS applications into Service Bus. You could take your Kafka clients and connect to event hubs.
Okay.
So that's plug for event hubs. But yeah, you get the idea. It's basically about streaming data that you want to do near real-time processing, or you would essentially store it, with event hubs capture onto a blob that you can then do offline processing as well. So that's where you can essentially use the event hubs or Kafka based setups.
Excellent answer. I was just curious what you will answer because I get the question frequently, because why are you using JMS, the old technology, and not the modern Kafka? And what I really liked in your answer is the direction. There is directing a message to someone. This is actually exactly why I answer the second part with Kafka. I answer a little bit differently. So what I usually explain is JMS and Kafka are actually 2 opposite architectures. JMS is usually not persistent. Kafka is always persistent. First, it's more database than a messaging system. And what I also say, if you know that you are directing the message to someone, so you're addressing someone like SMS, this is message. But if you don't care about the others, if you just, you are just storing your point of view, your state of the world somewhere, then it's Kafka. Because you say, at this timestamp, something happened, and I'm storing my context here. I don't care whether someone will read it or not. Then it's the perfect Kafka architecture.
Exactly.
And the funny story is, people come to me and they say, we don't like JMS, we would like to use Kafka. And the funniest, the funniest request I ever got is they wanted to have Kafka without persistence. And I jokingly say, okay, what you also can try to do is, you have JMS without messages is also even better then.
Well, I'll tell you what. There was a tweet from the Apache Kafka Twitter handle that says, this is a public service announcement. Kafka is not a queue. So if you have a queuing use case, please use any queuing. Just this is my PSA. Please use any message queuing setup, and preferably Service Bus. But don't use Kafka if you're using it for queuing. Right?
Yeah.
And another way to to say is that, whether you want to implement a server-side cursor or a client-side cursor. With the server-side cursor, the server decides what needs to be sent, when it needs to be sent, and who needs to process it. With the client-side cursor, the data is essentially thrown onto, a fat pipe, which is Kafka, but the client can decide when it wants to read and from what point it wants to read. That's why you have the concept of reading like a log and essentially rolling back your checkpoints and zooming forward and stuff like that, like a tape.
Yeah.
Right. So
but
that's
you're saying
Kafka
this,
fits.
yeah, exactly. But what you said right now is like the client would like to decide. This is right. But I would see, what a client sees is the state of now and the history. And now the question is whether the client is interested in the current state. And sometimes you need a window. Let's say you would like, to compute an rolling average of the last, 5 minutes. That's right. This is perfect with Kafka. With JMS, almost mission impossible. You will have to store somewhere. And what Kafka does, it is stateful, actually. It is able, to keep your state somewhere. So you can have such calculation, the computations. And JMS is just, simple messaging. Or you could use, cache invalidation. Let's say you have CDNs worldwide, and you would like to invalidate the cache. You could perfectly use your Azure service with a topic, and listeners which invalidate the cache or replicate the cache, for instance, right? You can use it because in CDN, it's not a big deal. Then Australia gets the message a little bit later than Germany, let's say. This is like, this is where you can perfectly use a JMS, and Kafka would be completely wrong because in such a cache, you are absolutely not interested in the history usually, right? Absolutely. Yeah. Yep. That's exactly right. So nice. And can developers just start and play with your bus, or what they have they call you or your manager, or how to start with Microsoft Azure Service Bus? It's absolutely self-service. They can just go to the Azure portal. It's portal.azure.com, as simple as that, and go and provision a brand new service bus namespace for themselves. Okay. And utilize the connection strings and start chatting with it. And how expensive is it? So if I would do it and play with it, do I have to pay something, or probably yes? But can I? Is it developer account or something like developer program or whatever? So we do have a free tier for Service Bus Standard, which allows you a certain number of operations. Apart from that, once you're done with the free tier, Service Bus has, I think it's a consumption-based plan. So you pay for the number of messages you use apart from a base charge. And the Service Bus Premium, so actually for JMS 2.0 full support, you will need Service Bus Premium. Okay. That's the only place we support it. That comes to, I think, about 90 cents per hour, and we bill on an hourly basis. So on a per MU basis, actually. So per MU per hour is about 90 cents. Yeah, but this you should change. I don't know whether there is someone higher than you at Microsoft, but I would propose that have JMS 2.0 in the free tier for developers, because otherwise it's hard to try out. Yeah, I understand. The part of the idea was that if there's customer demand, we'll definitely consider it. But the idea is that a lot of folks needed the free tier so that they could try out their test and developer workloads. And the reason we at least wanted it for now was to say, if you have a localized ActiveMQ that's running, you get the exact same features. And with Spring, because you have Spring profiles, and even with Java, you can have different running modes for dev, test, QA, and prod. You can actually switch out the broker as appropriate. So that's something as a workaround temporarily. Temporarily. Because for me, I have to admit, I would never try Azure with proprietary API. Really, because the time is too pity. So if I would do something, then with the standard APIs, familiar APIs. So just my feedback. So I wouldn't care about 10 messages per day are okay, but I would like to have my standard APIs. This is my personal take. I understand. Cool. I understand. Anything you would like to mention which you forgot? Or we covered all the features? Probably not, but I think we covered all the features. Obviously, the core value add is to make it easy for customers to migrate to Service Bus from their existing Java Spring workloads, and at the same time leverage everything else that comes in with the cloud native messaging PaaS offering. I encourage everybody to try it out. And if there's any queries, comments, concerns, feel free to reach out to askservicebus@microsoft.com. Okay, perfect. And we'd be happy to chat further. How people can find you on Twitter? My Twitter handle is AshishC1, so ASHISH
C1.
And
I couldn't get the
GitHub, do you
one
have still
within one.
GitHub as a manager, or you just just doing PowerPoint?
No, I still get to dabble with code. So my GitHub is AXISC. Yeah, and we can add the links.
Okay, then the last how to call it mystery about me. I never did actually a Spring project, but I did a lot of JMS. So for me, it is a very interesting discussion because I could use it in all my application servers, microprofile runtime, so it was still added value. Also, I don't like XML a lot, but still nice.
Well, the thing is, because they sort of realized that, and they realized application properties would be a little less cumbersome.
Yeah.
But yeah, you still have to work with the POM XML because of Maven and the dependency injection.
In application servers, my Maven is 40 lines of code.
Wow.
You see?
That's not bad.
Yeah, this is you have to ask Bruno Borges about me. You will find out how I operate. So it's 40 lines of code. So it's very, very thin. And let's say this: application properties is shorter, but this is we are in a brief moment of happiness because what I already see on the horizon, YAML.
Yet another markup language.
If we get the YAML, I mean, then I would rather would like to have the XML back. I would say. Okay, thank you.
I hear you.
Okay, bye.
Thank you, Adam.